basically the way we divided the subjects is I'm going to do the more sort of algebra stuff, and Dell's going to do the geometry and statistics kind of stuff. So if there's anything like sort of algebra-wise that you would like for me to discuss, I can do that. Otherwise, my plan is basically to kind of go over the sort of problems like you saw in the post-test, give a little bit of detail to the sort of theory behind the problems, just to try to strengthen that, and then make sure that we know how to solve those problems on the post-test. Is that cool, or?
Yeah.
Get those scores back?
What's that?
Get those scores back?
Yes, I did, yeah. I mean, I don't know.
How you do?
If you wanted to know how you did, I can't tell you because I don't know. It's just by number, right?
Did we improve?
But that I don't know. So I don't know how you did on the pre-test. But there were some problems on the post-test that had very low numbers. I will say that.
Everything?
So, no, not everything. Not
Your
everything.
last problem?
And also, like, you know, it's divided by region, and so I can't remember which regions I looked at, which ones I didn't.
Finish.
Okay.
Like I didn't
So-
finish like
What's the Dulles region? The Scranton.
Let me start with the problems.
The Scranton Heights, invaded Dulles. Sorry. Delete that.
Yeah. We have to sit on the other side. Mask our voices.
My name's Mark now.
Not interrupt, I'm just gonna pass this around, I don't need to say anything. This is the Dropbox paper, so if you would just provide your name and email that you're going to use for Dropbox. And
That's more my stuff.
can somebody hand this back in to me whenever it's done with
Non-incorporated pages with the.
Well, I'm actually gonna have to fix that edge. I can't accept the
I tell my kids you are what you turn in. Except for your crumpled, wrinkled mess, that's what you are.
right in.
Okay, so try these things.
I can tell you right now, it's one of the ones I didn't know about this.
You have a negative exponent, flip it. The nth root is the same as 1 over exponent. If you want to take the nth root, that's equivalent to raising the number to the 1 over the n half. It's good.
That makes sense.
Right, so really what we did here was first convert to 1 over x to the 1/3, and then use the reciprocal rule to get this final answer.
Can you just prove that with like a 2? I mean, like that with a equals 4. Could you just?
So you
So it
mean,
would be the square root of 4 equals a to the.
right, so, okay, so here, you want to example as a number, basically, is what you're saying. So, first off, it's important to understand what, I guess, a root means. Okay, so what is, for example, the square root of 4 means?
The number times itself.
So, remember, you think in your mind, there should be a little 2 there, right?
Right.
Okay, so
It's on the wall.
So let's put a question mark. The answer to this question is the number that when you multiply it by itself 2 times gives 4. Right? So I think it's important to understand what a root means. So if I sort of generalize this, what does the nth root mean?
How many times the numbers repeat?
I'm looking for some number so that when I multiply it by itself n times a is the result, right? Okay. So why does that make sense for this to be this also? Why should the nth root of a number, why should the square root of 4 also be 4 to the 1/2?
Well, it's the reciprocal of 2/1, but I don't know.
What is
How
it?
to-
The square root of the square root.
What does it mean to multiply 4 to the 1/2 by itself 2 times? It means 4 to the 1/2 squared, right?
Okay.
Right. So what do you get if you take 4 to the 1/2 squared? Well, if we use those rules of exponents, right, here's another rule. An exponent raised to an exponent is equivalent to doing what with the exponents?
Multiplying.
Multiplying. Right? So if I applied that rule here, what do you get? Well, what's 1/2 times 2, right?
1.
2 over 2 is 4 to the 1, which is 4. You see what I'm saying? Are you following my logic here? That's why this should be the square root of 4. Because this number, whatever, I mean, we know it's 2, right? But pretend you don't know what it is. By just following the rules of exponents, 4 to the 1/2 is the number. When you multiply it by itself twice, you get 4. You see? So I'm just trying to justify the equivalence between roots and raising to fractional exponents. Yeah, so someone explain this to me. What did we just do?
Explaining that last one there.
Yeah. Or explain to me why these two things should be the same.
Because the square root of a number means that number times itself, so you took that number and times it to itself, which is raising it to the second power.
Does everybody see? Do you understand what she said?
I guess I was looking at it as the square root of 4 should equal 2, so in my mind I was thinking I should get a 2 for an answer.
Right. That's true,
Just
right?
defining
And
this
this is
one.
really 2. This is 2 in disguise.
Right.
Okay, so let me put a little 2 there, right? That's really 2.
Right.
But the point is, 4 to the 1/2 is some number. What number is it? What's the number when you multiply it by itself 2 times, you get 4. You get it. So what would be a to the 1 over n? How would you explain that to your kids? What is the number a to 1 over n?
I have them focus on the denominator there to say that's what, that matches that notation. Shoot, what's the name, there's a name for that little number that goes in there, but but that's the same as when we look at it as the square root of 4, looking for that factor that's used twice.
Right.
So we're looking at the denominator right there.
Right.
I think the kids get confused because they see a fraction, which we've told them is a little bit like division, and then they have that radical sign, it looks like,
Right.
so that's where their confusion comes in sometimes.
So, let me do this for a minute. So everyone agrees that this is just notation, right? I mean, it has some meaning that we assign to it, but suppose this notation never existed, and all I had was this. So forget about square roots, forget about cube roots. Suppose the only thing you know is exponents. Then what does that mean? How would you explain what that means?
I'd probably still explain it the same way, that that denominator is telling you how many factors you're looking for, like factors you're looking for to
Right.
get the base to get.
Exactly, exactly. It's some number, so the answer is some number, such that when I multiply it by itself n times, I get a. So, let me write this. A to the n means some number, let's call it b. b. Write it smaller. You get it? And I mean, I think the reason why understanding this statement is important is because if you're ever going to teach about exponentials and logarithms, then it's the same sort of definition for defining the logarithm in terms of the exponential. I know that's not a topic for this sort of session, but there's a tie-in, and I feel it's important to point out. Questions? Is everybody happy? No one looks happy. So then when these questions, if you had to take the post-test again today, would you be able to answer those questions correctly? Questions involving this kind of stuff. Okay, so then let's try something slightly different. Have you seen a problem like this before? But now you can, yeah, good, exactly.
So that's,
Mark.
so, okay, cause I was like, I wasn't sure if that's something.
You get it? You got it.
Now, how do I write the cubed root of 3 instead of writing it under a square root?
Whatever,
To 1/3.
What do you know
It's
about?
all raised to 1/3 power.
I don't know anything. I wanna say like, this would be like, so you do the 1/9 power, is that not right?
Well, I mean, close, it's not 1/9 because that's not a fraction. But it would be, so it's negative all this stuff to the 1/3 power, right? And then
So I
reduce
always
from
take
there.
what's inside the square root first,
what I'm saying?
rewrite that.
So just 3 parentheses to
And then
this
divide
one,
it
this
out.
power.
Reducing it and then writing.
Well, to the
Yeah.
3/3
Because they wanted it in the form
in the
of
denominator.
that.
So
Now,
this
if
is-
they, if the direction
So
said write it
this is
with
gonna be
only
x to
positive
the 6 to
exponents,
the 1/3
X squared,
x
y
to
to
the
the
6
third.
thirds.
divided by
Z.
Oh, no, so
Right.
you do 3/3.
So sometimes the directions will ask for it, but we don't write.
And that's how you write it?
Well, so that's the first
But I
step.
think it's
Oh.
actually
And then the last step is
easiest to
to
put it all up and then.
get it
like
all-
that.
That's the one thing I don't want to do.
Because if you get these
You could do a team, so teach
that way you're not gonna be
I've done it twice.
Yeah, but if you're gonna put it up here, you
You have to have
need.
two though within your unit, right? So if you're working with a group, you only need.
Because
Oh.
it's in the-
You
No,
individually
sorry,
have
just
to
say
have
that.
Everyone
Because that's the
has
guy
to
that's in the
finish.
denominator originally.
Just kind of like point the camera high.
Okay.
Or have somebody like take it. That's one thing I don't want to do.
It's- Yeah, so that's right.
Versus a lecture.
I'll come film, I'll take a day off and film it.
Well, the news week out was. Then I'm probably
Okay,
looking
so
at
what did we get?
At least, probably somewhere in the 35 range for all 4 sections.
6/3.
Because they switched the other 6 for team.
Y, or do you want it reduced?
Makes me-
Yeah, just give me the final answer and then I'll go.
X squared, Y cubed, Z to negative 1.
And last year I had 35, 33.
Okay, and most people get this? Okay, so what's the explanation?
At least 30
That's what I'm guessing. 'Cause
The
I-
room is that big, can you even hold that?
Why is that the
35
answer?
is the room.
Well, I'm just kind of curious if this, initially, like when I first saw it, that's what I got.
Mhm.
And then I did it out and I got the same answer, but I don't know if there's like a coincidence, but whenever I see something in the bottom, I know to bring it to the top with the negative
Right.
exponent, so then I just divided them all by the little thing of 3 that's in there.
Good.
Index, that's what it's.
Yeah, index, yeah.
Okay, so first, she said we're gonna rewrite this, because that's something in the denominator, I can bring it up if I take negative exponent, right? So you do cube root, x to the 6, y to the 9th, z to the minus 3. What does the cube root mean in terms of exponents?
1/3.
To the 1/3. So this is x to the 6, y to the 9th, z to the minus 3 to the 1/3. And now if you raise exponents to exponents, you just multiply. So what is 6 times a third?
Is 2.
Is 2. What is 9 times a third?
3.
3. And what is minus 3 times a third?
Negative 1.
You got it? Pretty okay.
This was the last question of the test.
Any questions?
You get it.
So we have to do this on the test today. Thumbs up or thumbs down?
We should take a portion of the test after each day.
What type of problem
After I
was
learned
this?
this, I take the test.
What type of problem? Just another problem with exponents. What are the other important rules for exponents. You remember? Just think this one. What can you do?
Not it right now.
You multiply two exponents of the same base.
Oh, yeah.
You do that.
Yeah, thank you. I'll wait for that.
And then what else can you do?
Division rule?
Yeah. If you divide two exponentials with the same base,
You subtract.
you subtract exponents. What's the order of the subtraction?
N minus M.
Yeah, the top minus. I think that's about it. Any questions? For these rules, like, yeah, I definitely know those, or what do you guys think? Are these rules, you definitely know them, or
Are you familiar? No.
are you seeing them?
I got it.
So this trip.
This was a normal.
Yeah, I guess. This reminds me of the Seinfeld.
They'll get there Tuesday at 8 AM.
Which one was it about?
Seinfeld when Kramer takes Jerry's car to the test drive.
So it says a car can get 15 miles per gallon of gas and drive 30 miles per hour. Car has a 10-gallon gas tank. For how many minutes can the owner drive before running out of gas?
Assuming the exponents itself.
So what type of problem is this?
Proportion.
Yeah, proportions or units, right? So basically all you have to do is convert the units. See if you can do it.
Did you get it?
I didn't guess, you did something.
I put 15 miles over 1 gallon equals X over 10 gallons and got X equaling 150 miles per tank. And then divided that by the 30 miles per hour and got 5 hours and then multiplied by 60 to get the minute.
So the question asks for minutes, right? So you know whatever you do, end up with the units of minutes. So we have to figure out what we have to do in order to get that. So let's think about what we know. You know 15 miles per gallon, right? And I'm gonna have to get both of these to cancel out. So what's the next thing you can do in order to get either miles or gallons to cancel out?
Gives you the
10 gallons.
Yeah, so we got 10 gallons. So that's not a problem. To get gallons to go away, there's just a one there with no units.
Yeah, gallons are on the bottom.
Here, so these two will cancel, right?
Oh, okay, oh, I see.
It's one
That
tank.
was one of the questions we came up with.
10 gallons over one
Yeah,
tank.
but it's. Whether it was a.
Yeah, right, so that's.
So then you wind up with 150 miles per tank,
Right.
because the gallons cancel out.
So if you set it up as a unit conversion problem, what looks like that, what we talked about back here is, if you set it up as a ratio problem, the result's gonna be the same, the look of it's gonna be different, which I think somebody said about the X per
Right.
per gallons there, so I don't know whether it would depend on whether you're thinking about what topic you're making it part of, like where in the curriculum you're teaching it, how it would show, or whether it's something that you're revisiting.
Yeah, so that's a good point. I mean, I was treating it as a units problem because that was one of the topics for the session, but what do you think is easier for students?
The
ratios,
so
ratios.
our kids can get that.
Okay, so let's finish this way and then we'll go back and do it the other way.
So 1 hour over 30 miles.
So we can do 1 hour. Oh, so that's not right, because we want the minutes on top.
She said 1 hour over 30 miles, I think, right?
Yeah.
Yeah. And then-
Okay, that's good, yeah. Cool. Okay, and then,
150.
60 minutes over.
Yeah.
is that good? There isn't cancels? This we don't really care about. And what's the result?
300 minutes. And you could leave that tank unit in there, because it would be 300 minutes per tank. It'd still be okay.
Probably better. Does this make sense, like, the whole unit, idea of converting units and stuff?
I like that some of it said about doing it as a ratio problem, because I think that's where we come in with it. The students sometimes is, we understand one way, and they're coming from a different direction.
Right.
And I know I have to stop and listen sometimes to what they're saying, instead of saying, no, just do it this way. Because that was why I back here, how did you do that? And then, okay, that's great, now I have another tool when the kids go, okay.
Right. Yeah, that's a
So,
good point.
yeah, the ratio kids will be able to do it.
I mean, I understand that way, but I've never done a problem like that. I mean, it makes sense, but I would have never thought to do it that way.
We used to do it that way in sex.
And I think that's coming from, like I said, I think the science too, that they have the students rearrange their equation first, get everything to here equals this number, and they do all that unit conversion.
Right.
Where we come in initially in middle school with, we're gonna work at solving proportions, and that's, we have to somewhere make it meet, so it might be something that we move towards that one right there.
Or we talk to the science teachers and see how they want it set up, and we just do it the same way as they do, so they can see that this applies to that.
But that's important for me to hear that the middle school's doing a lot with the proportions, so that instead of me just hammering with this right away, to move in that direction.
That's good. I mean, I like the proportion idea, but I also think it is important to understand unit conversions, especially for connections with applications and stuff.
I think the proportion, when you set it up like a proportion, it helps flow into solving an algebraic equation.
Right, yeah. So like it fits more within the topic of algebra and then
Yeah.
this, that was really. Any questions? Let me move on to this. Okay, so how does everyone feel about lines and equations for lines? That's what I want to do next. Lines and some related stuff. Okay, so what would you say are sort of the basic facts about lines and equations of lines?
Standard equation?
Yeah, so there's a bunch of different ways to write an equation for a line, right? So, but first, if you're going to write an equation for a line, what kind of information do you need?
God bless you.
So let me, so there's three forms. Okay, so what are they? Slope intercept, that's probably the most popular, right? Intercept. And what's the form of that equation?
Y equals mx plus c.
Here's the, what kind of intercept?
Y.
What's the information that you need to know in order to write an equation for a line in the slope-intercept form? Well, you gotta know the slope, right? You have to know the slope and what else?
Why?
Either the y-intercept
Or a point on the line?
on the line, right? Because if you know point on the line, you can plug in and solve for b, right? Do you have any idea what's the benefit of this form? Like why would you use this form over the other two?
Because it helps you understand what the line represents and what the parts of the line represent, because when you're talking about like rate of change and you're talking about
That's-
you
yeah,
know,
that's the
those
key
key
word,
things
right?
that you need to know about in this form.
Right. So one thing that's nice about this is it's easier to graph lines. I mean, at least to me, it seems like students have an easier time seeing how to graph lines in the slope-intercept form, right? Because they can just rise over run kind of thing, right? So for graphing, this is nice. And then what's really great about this is what the key word she said is the rate of change. Let me write. So what is the average rate of change? The slope, yeah. It just is the slope. So, I mean, sort of somewhat to my surprise, we had a problem like this. So I'm kind of paraphrasing, but this was a problem on the post test. And a little bit to my surprise, the number of correct answers to this question was fairly low. But why is this really easy?
Because that's what the rate, the slope is the rate.
Yeah. Slope is the average rate of change. What's the average rate of change in terms of position and time? It's speed. So the answer should be 1/15. And what's the units? Whatever, distance per time, right? If it's feet per second or miles per hour. Yep. You get it? Any questions? Yeah, you can turn on the air if you want. Any questions about this? Do you see, like, when you saw this problem or these types of problems on the test, what type of problem did you think it was?
I was mixing myself up and thought it was some sort of like formula or like I like, you know.
Right, something harder than what it was, right?
Some sort of formula that I was like, yeah.
So maybe it's just that you kind of like psyched yourself out rather than really. What do you guys think when you saw this problem on that?
No, I did the same thing. I was trying to put some sort of rule into it. I never put question mark.
I don't remember seeing this.
This was question 2.
Do you guys remember seeing something like this?
Got it right.
Crazy, right? So, like, when you see the equation, notice the equation for a line, if it says average, then it's asking for average rate of change, and the average rate of change for a line is the slope, right?
I said I kept trying to put a rule into it.
So no big deal there. Okay, so suppose you have in general a function. y equals f of x. In general, what's that average rate of change for a function over an interval?
We're talking about change in the distance compared to the change in the time.
So it's basically the change in the y values divided by the change in the x values. So the average rate of change so this is more general than what we're talking about with lines, right? So if I say this in words, it's kind of the, let's say change in y divided by the change in x in words. But if f of x is a linear function, what is the change in y divided by the change in x? It's the same thing as rise over run, so it's the slope. That's a distinguishing property of lines, is that they have a constant average rate of change. Would that be true in general for nonlinear functions? No. So this is the distinguishing property of lines. Average rate of change is constant. Got it? So the significance of the statement is the problem that I had raised, that was right here before, right? It asks you to find the average speed, and the speed's determined by a function that's linear, then you just write down the slope. Okay, so what's the next, or what's another way to write an equation for a line?
X plus by equals c.
What is their name for that?
C.
What's so great about standard form?
I want you to find that intersection.
It's easy to find the intercepts. So remind me now, what are the intercepts? How many intercepts? How many different types of intercepts are there? there's the X and Y intercept. So what is the X intercept?
From the goal.
Good. Where it crosses the x-axis for the x value. And y is 0. Okay, so if I have the equation in this form, what would be the x-intercept in general? Array. Do we have a caveat? What is that? Provided A is not 0. So what is the y-intercept in general? Here. Draw a line. X-intercept. Y-intercept. So what is the definition of
Same thing, but when X is 0.
And if I have the equation for a line written in the standard form, what is the y-intercept? What does happen if a is 0? What kind of line do you have? What's that? What kind of line do you have if a is equal to 0? Yeah, you have a horizontal line. Because you just have a constant y value, right?
Right.
So what happens if b is 0?
Yeah, vertical line, vertical.
Flash.
So this form also makes it easier to identify, right, vertical and horizontal lines. Which aren't that hard to identify anyway, so. Something we can do. What about the third version? Equation for line.
One slope.
So what is, oh no, wait, sorry. We already did. Oh, that's okay. Okay, so what is the point slope?
Y minus y1 equals n x minus x1. X minus x1 in parentheses.
So what's the necessary information? What do you need in order to,
Two sets of coordinates.
you need 2 points? In order to write this.
If you already have the slope down.
If you already have the slope, then you would only need 1 point. So it's before. What's so great about this version? It's like one of the key sort of facts in geometry is it takes 2 points to determine a line, right? So you got 2 points, now you can determine an equation for the line. Do your students like this? Do they like point slope? Like compared to the other two?
I've found that kids, they kind of, once they start using that, they kind of lose sense of what everything represents. And I think that the y-intercept form is really more meaningful for them, especially when you're transferring between word problems and you're asking them to interpret a graph in terms of context of the problem and things like that.
Right.
I think this kind of mulls things. I think it offers them a shortcut, and they're all into shortcuts, but then they really can't, like, they forget about, like, what everything means. So, I don't know, with our low level kids, we didn't even really do point slope, because if they give it to them in that form, they know that they have to get it in y-intercept form to be able to interpret it, so they end up, so.
The reason why I like this form is because when I teach calculus, the students spend half the semester finding slope, and then ask them to find an equation for a line, and the information they're given is a slope and a point. So if they have a slope and a point, this is the best form. This is the easiest way to get an equation for a line. But they always never seem to remember point and slope. They always want to do everything in terms of slope intercept.
Yeah.
So I just think that was interesting. So yeah, so this is good if you only have 2 points, or if you have a slope and a point that's not y-intercept. Especially if this is not super convenient for finding the x and y intercepts, right? Because you set y equal to 0, you have to move this to the other side, multiply this out, solve for x, right? So that's kind of a pain. Maybe it's just helpful to know. So let's try some line type problems. For these short. Get it?
Say X is 4, Y is 3.
Is that right?
Yeah, I wish I would have known that shortcut. 'Cause I don't even know what I think that's crazy and stuff.
So suppose you forget the shortcut. You want to find the x-intercept. What do you have to do?
So the difference.
Plug in, right? Y equals 0. If you do that,
It's just 12 over 4, right?
Yeah. Oh, sorry, so it should be 3. No, wait.
No,
That's what
I
you
mean,
said.
for
Four is
Y.
12.
That's, yeah, for the what, yeah.
Okay.
0.
So y equals, we'd wind up with 4y equals 12.
Well, I just did that thing that you said, right, to just put C over I.
Right.
Or C over, or whatever, basically.
I was just pointing out, so you can do that if you remember, but if you forget,
Right.
just go back to the definition of what x and y intercept is, right? Questions? Okay, so see if you can put this into slope intercept. So the reason why I talked about the 3 different forms of a line is because I want you to be able to recognize
Warming up.
when you see one of these in a problem, if you're dealing with a problem.
Thank you.
Involving Okay, so what is it?
You move. Oh, it's y equals negative 3/4 x plus 3.
So what everybody got? How do you get that?
I move the 3x to the other side. So I subtract it. So I got 4y, yeah. And then I divide it by 4 on both sides. Superstar right now.
So now, if you see one of these 2 problems, if you had to take plus test again today, comes up or comes down?
Yeah, I got that one right. I know I did.
Because if you don't have to get y and stuff.
Change in Y.
Yeah.
change in
Equate
Y.
to get rid of positive 3x.
Yes, you mean just like use
So it
information
becomes
there.
negative plus y.